So what we're going to be starting to take a look at today is this concept of rational exponents. Now, as we go through these, I'm going to tell you this. You guys need to know these. Now, obviously, I'm not going to be able to, or would I, give you a time test on all of these powers. But the thing is, if you guys don't have some concept of what these powers are, as we move forward in our exponentials unit and our logarithmic functions unit, it's just going to take you forever. So if these are the ones that are going to end up coming up the most often, so maybe you want to pause this, write it down, make yourself some flashcards. I think you got plenty of time on your hands these days. So these are the ones that are going to be the most commonly used and commonly talked about. Now, what I want you guys to know is that when we're talking about rational exponents, we're actually talking about fractional. Riley, my dog is going through a bag that is next to me right now. We're talking about fractional exponents. And I'm not going to make these problems super complicated. There's going to be some basic things that you guys need to know. Now, first of all, you guys know the square root of 16. The square root of 16 we know is 4. But I also know that I could rewrite the square root of 16 as an exponent of 1/2. Now, take out your calculators, plug it in. You guys are going to see that if you put 16 to the 1/2, it's going to equal 4, just like the square root of 16 does. And the reason for that is because if I had 16 and I rewrote it as a power of 2, well, I could do that, raised to the 1/2, then I end up with 2 to the 4 times 1/2, so 2 squared, which is 4. So anytime you guys see an exponent that is a square root, you can rewrite that so that it is to the 1/2. And so if you know the square root of 225 is 15, great. So we could express it as 15 squared to the 1/2, multiply those exponents, and then we get 15. So the big takeaway here is if I have the square root of x, assuming that x is a positive number or 0, that could be written as x to the 1/2. So this is one of your very important facts. Ryan just woke up. You want to come say hi, bud? No?
What is that?
You can say hi.
I'm mad at my sister now.
You're mad at your sister? Why?
Oh, my thought.
Oh, Daddy put her there. All right. Okay, I'm going to finish this and I'll feed you, okay? All right. So, this whole e-learning has proposed several challenges. One, I've been staying up till 2 a.m. to get all my work done, and that was not working well, so then I got up early, and so did the kids. All right. Now, here I have cubed. Well, 27 cubed, or the cube root of 27, hopefully you guys all know, is 3. So I can rewrite that. Go ahead, check it in your calculators. It's going to give you 3. The cube root of 64 can be 64 to the 1/3. And again, check it if you want to. But if we know that 4 to the 3rd is 64, and I raised that, well, that gives me 4 to the 1st, which is simply 4. So your second big takeaway is if you are dealing with the cube root of x, that is going to equal x to the 1/3. All right, that's a must know. And then one of the last ones we're going to look at for a second is this whole concept of the 5th root, the 6th root, the 9th root, the 12th root, whatever root I want to make this. So what I need you guys to know here is whatever number this is, is that's going to be the denominator of your fractional exponent. So here I have the 5th root of 32. So that's why that became 32 to the 1/5. So the way that we write this general rule is the nth root, say, of x is going to equal x to the 1/n. So these are like the basic rules of rewriting things. Now, all of these problems are when our numerators of our rational exponents were 1. And unfortunately, they're not all going to stay like this. So the last type of problem that you guys need to know is that if you were given the nth root of x to the m. So now I have an exponent on the inside. Sorry, I got bad shadows going on here. And so with this exponent on the inside, I can go ahead and I can rewrite this now as x to the m over n. Now, one other way you'll see these is sometimes if you're starting with x to the m over n and you need to rewrite them as a radical. There's going to be 2 ways that we can do that, and I'll go through some of these problems with you. Well, my n goes here. That's not questionable. And so when I have the x to the m, I can put the m on the inside of the radical. Or it's also equal if I did the nth root of x and then I raised that to the m. So knowing that these statements are equivalent and how to go from one to the other and evaluate these is kind of what we're going to look at right now. So I'm going to give you all an example. Now, if I gave you guys the 6th root of x to the 3rd, and I asked you to rewrite that as a rational or fractional exponent. Well, I end up with x to the, well, that's my index, so I'm going to put that in the denominator, and then this in the numerator. And so this ends up giving me x to the, I can simplify 3 over 6, which is 1/2. Now, if a question asked me to leave it as a rational exponent, this would be my answer. This is my answer as a rational exponent. If it wanted a simplified radical, the square root of x would be my answer. Now, let's take a look at some that have a little more to it. So if I gave you guys the cube root of 27 squared, well, I can look at this as the cube root of 27 squared. So say I'm just told to simplify. Well, if I have the cube root of 27 squared, I can work with it like that. Or I can look at it like the cube root of 27, and I can put the squared on the outside. Now, the reason that this is helpful is, the truth is, I have no idea what the 27 squared is. I don't. So that's not as helpful of a form as for me. But if I take a look at this one, the cube root of 27, then squaring it, well, I know the cube root of 27. I know the cube root of 27 is 3. So this one I'm far more comfortable working with. So I end up with 3 squared, which is going to leave me with an answer of 9. Now, say I don't even know that. One of my other options, though, is if I'm looking at the cube root of 27 squared. you want to look and say to yourself, well, can I rewrite this 27 as a power? Well, when we looked at our list from before, there's the 27. So we know that 27 is 3 to the third. So now I can go ahead and I can rewrite the 27 as 3 to the third squared and the cube root of that. Well, our properties of exponents tell us that I can multiply those. So I'm left with the cube root of 3 to the 6th. Well, here's the sweet thing about this now. If I take the cube root of 3 to the 6th, well, one, you guys should know that you can just divide that 6 by 3 and we get 2. But you also know now that we could rewrite that as 6 over 3, which is 3 squared, which does give us 9, as we suspected. So you're going to have to be able to go back and forth between these, and you're not going to get super complicated problems. But if you are given a problem that says x to the 4/5, and I ask you to rewrite that as a radical, well, the x is what goes underneath. The denominator is your index, and that's what that's called. And that 4 can either go on the inside or it can go on the outside. I take either one. Both of them have their place. So say I gave you, though, 64 x to the 5th raised to the 1/6. Now, and I asked you to rewrite it in radical form and simplify. Well, this 1/6 belongs to the 64 and to the x to the 5th. So they're both going to have to go into the radical. So I have the 6th root of 64 x to the 5th. But if you guys recall from our list again, I've got 64 a few times here. So, and it's also 8 squared. So if I'm looking at these and I want to rewrite this, well, if 64 is 2 to the 6th, and I take the 6th root of 2 to the 6th, well, that's going to let me just do 2 times the 6th root of x to the 5th. And as long as this exponent is smaller than this one, that's as simplified as it's going to go. So I'm going to give you guys some practice problems on rewriting from one form to the other, and then we will move forward after that. We do have a Zoom meeting today, and so we will chat a little bit about this, but I'll take a lot of questions on those exponential functions. I miss you all. I hope you guys are doing okay. Obviously, I still have not gotten nail polish remover. The whole idea of going to the stores and seeing those toilet paper rolls was a little scary, so I only sent my husband, and he doesn't know where that is. So, have a good one, and I'll see you later today on our Zoom meetings.